And I'm like, what are you doing? And she's like, "It's like, what?
All right, so this is what we did last class.
Like this tall. She's like, what the hell?
We reviewed solving inequalities. This could come up as an important thing in composition of functions, where one function is inside of the other. And this becomes really important when, for example, in this second one, if I asked you, what is the domain of the square root of x squared plus x minus 6? The domain is where the x values work. Where do x values work inside of a square root? They work when the inside is greater than, and there would be an equal sign there, because equals 0 would also be true. And then you would have to solve this inequality. The only difference here in the blue would be that these circles would be filled in with a square root, right? Because it could equal 0 as well. And so the domain of the square root of x squared plus x minus 6 is that x would have to be less than or equal to -3, or x would have to be bigger than or equal to 2. And because that equal sign was there, if you did it in interval notation, it would be a square bracket. And this is a composition of functions because it's a parabola that got put inside of a square root. You could figure out what happened in the parabola first. That would be machine A. And whatever answer you get, you square root it. That would be machine B. So this getting started helped us with questions like this, where one function is a square root and the other function is something else. We want the domain and range of both f of x and g of x. Now, I'm going to do f of x in green first. I'm going to draw a little graph of it. To graph the square root of 3 minus x, you can either use transformations or you can use what we learned in chapter 2, where you square root any graph. I will do both of them. I'm actually going to draw 2 graphs. I think the better method in this one is chapter 2. The inside minus x plus 3 would have a y-intercept of 3, an x-intercept of 3. I'm just drawing with the dotted line, and would look like this. What did we learn in our square root graph unit? Is the values where x is 0 and 1 stay the same. Between 0 and 1 on the y values, your x graph will be slightly above and then below after that. And that would be the graph of the square root. If I use transformations, I would rewrite f of x as the square root, factor out the negative, and have x minus 3, which would mean my regular square root graph had a horizontal reflection and then was moved 3 to the right. If I imagine that and I draw it out, flipped over, moved 1, 2, 3 to the right, here are my key points. I get the same graph both ways. Okay? Using transformations, I had to remember to factor out the negative. It's good review for doing that, but it's also good review of chapter 2. How do you square root any graph? You draw the inside graph first. 0 and 1s are going to stay the same. When the y values are between 0 and 1, your graph is slightly above. When the y values are bigger than 1, the square root makes the number smaller. So either way, there is our green graph. Then also, this one's a little bit easier. In blue, my blue graph, I'm going to go a parabola shifted down 1. So this one. So the first thing, it says domain and range of my green graph. Well, now that I've done it, x is less than or equal to 3. The range y is bigger than or equal to 0. For the blue graph, my domain is everything, and my range is greater than or equal to -1. So that's a good review of some of our previous chapters. But now we're going to do the composition. We're going to do f of g of x on the same group and see if we can figure out the domain of f of g of x, and we're going to see if we can figure out what's the best way to calculate these things. So first of all, it asks us to do a table of values. This first column is just your blue graph. If you did your blue graph first, if you plugged in -3, you see that you would get 8. -2 squared minus 1, 3. -1 squared minus 1, 0. -1, 0, 3, and 8. Then f of g of x is just f of 8, f of 3, f of 0, right? Because we figured out the g of x first. So when I try to do f of 8 on my green graph, that's not possible. Because if I plug in 8, 3 minus 8 would be -5. I can't take the square root of -5. If I plug in 3, I get 0. If I plug in 0, I would get the square root of 3. I plug in -1, I get 2. 0 again would be square root of 3. This would be 0, and this would be not possible again. So if I were to draw a graph of f of g of x, and I'll do it in purple here. According to my table of values, I've got 0 here. Nope, sorry. When I plug in x is -2, I get 0. When I plug in x of -1, I get square root of 3. When I plug in 0, I get 2. When I plug in 1, I get square root of 3 again. And when I plug in 3, I get 0. Can I plug in 4? I mean, I guess technically, can I plug in 3? If I plugged in 3, I get 8. That's not possible. So it seems like this is the answer to my graph. Is that kind of weird? Is it right? How would we know? Okay, just using a table of values gives you an idea. In this case, that is the right graph. The domain of this graph is that x is in between -2 and 2. The range of this graph is that your y values are in between 0 and 2. But sometimes just doing a table of values is not that helpful. Okay? And actually for this one, what we're going to do is we are going to find out algebraically what is the equation of y equals f of g of x. And this is where we used our composition of functions the other day. G of x was given to us. I can replace the g of x with what? My equations, g of x was x squared minus 1. And then if I went to my function f says whatever you plug in, go 3 minus whatever you plug in, and then square root it. So f of x squared minus 1 will be square root of 3 minus, and this time I'm plugging in x squared minus 1. If I simplify this, I'm going to write the negative x squared first, and 3 minus the negative 1 will be plus 4. That's the square root of negative x squared plus 4. If I wanted to find my domain algebraically, the negative x squared plus 4 has to be bigger than or equal to 0. It's an inequality. How do we solve inequalities? We temporarily make it equal to 0. So x squared equals 4. X equals plus or minus 2. Draw our number line with minus 2 and 2. Draw open circles and decide, do we fill them in? Yes, we have an equal sign. So they're included. And test things. If I plug in something like minus 3, does it work? Minus 3 squared is 9, times the negative would be negative 9, plus 4 is negative 5. This section is false. If I plug in 0, 0 plus 4 would be 4. 4 is bigger than or equal to 0. This section is true. And this section is false. So I could see that my domain is equal to that algebraically. When I just did my table of values gave me I was like 80% confident it was going to work. I wasn't complaining. I was like, yeah. Now that I've done it algebraically, I'm 100% confident that is the right domain. Okay? I drew the graph just based on my table of values. I think I was 72% confident on just the table of values with the graph. Because it had x values and y values, I wasn't sure. Algebraically, if you had to graph this, you would go back to chapter 2. You would say, how do I graph that? I graph the inside first. I'm going to graph this inside first in blue. I'm going to do a negative x squared parabola, flip down, move up 4 units. 1, 2, 3, 4. Down 1 over 1, down 1 over 3. There's my graph of my parabola. How do we draft the purple one if we are doing a square root? Wherever it's 0 and 1. Actually would have done that point and that point, 0 and 1. Slightly above, and then square root of 4 is 2. Look at that. That's more accurate than my graph. Maybe needed to be a little bit steeper than it was. My graph still would have got full marks because it was close enough. But now now when I draw that graph using chapter 2, I feel like I'm 100% confident that that's the right graph. So we're going to find with the composition of functions, we're going to like to do the algebra. Because if you look at the original domain, right? X is less than or equal to 3, X is bigger than X is everything. Look at the answer of the new domain. Nothing to do with the original domains. There's no hints whatsoever. Same thing with the range. Yeah. There is no way I could look at this green and blue domain and say, oh, I know that it's this. I'm not very helpful whatsoever. So the algebra is going to be the most helpful thing. We're going to do the algebra and figure out the explicit equation of the composition. Once we have that, we can use skills from our other units to find the domain and range. With that, we're ready for example 1. We've got the function f, we've got the function g. State the domain and range of each function. So again, it's helpful to see these And by now you should be able to take most graphs and get a sketch quickly. So, x plus 1 y-intercept of 1, slope of 1, there's my green graph. G of x equals 4 minus x squared. I might even rewrite g of x to be minus x squared plus 4. It's a parabola. Vertical reflection. That is a plus. Did I write? Plus 4. Vertical reflection moved up 4 units. So I can quickly sketch that. So I have a picture of both of those graphs in my head. So the green one, because part A, well, it says we need to do the domain and range of the green one, the domain and range of the blue one. And we want to sketch the graph of both composite functions below. Then do the domain and range of those composite functions. Again, I could teach you complicated methods of using the two graphs to sketch the new graph. That would not be worth your time. Instead, I'm going to just teach you the easiest way is to get the explicit equation. So for A, we have y equals f of g of x. And I know what g of x is. So to get the explicit equation, I replace the g of x with 4 minus x squared. Because that's what g of x is equal to. Now the F machine says whatever you plug into F, you add 1 to. It's a pretty easy machine. Plug in a 5, you get 6. Plug in a 6, you get 7. You just add 1. So, if you plug in 4 minus x squared, you will get 4 minus x squared, and then you will add 1. Which, if we simplify this, this is negative x squared plus 5. How hard is this to graph? Not very hard at all. Again, what is this? This is a parabola. Flip down, vertical reflection, then moved up 5 units. So I go 1, 2, 3, 4, 5. Draw this one in purple. Over 1, down 1, over 1, down 3. What's its domain? Everything. What's its range? Y is less than or equal to 5. So if you find the explicit equation, you will have the skills to be able to draw it. And then part B, it wanted to do the same thing, but this time we have y equals f of x. Well, f of x is just x plus 1. You just add 1 to whatever you put in. Then f of x plus 1, well, if you're plugging in an x plus 1, you will get x plus 1, and then you will add 1 to that, which just makes x plus 2. Again, I'll draw this one in purple. Y-intercept of 2, slope of 1. Domain is everything. Range is everything. Pretty easy to graph. But if we hadn't done the algebra to find the explicit equation, it is really confusing try to visualize, what if you do x plus 1 inside of x plus 1? That's hard for our brain to process. But if we actually work through the algebra slowly, get the new equation, life is easy. Okay, circle question number 4. There was no green light on.